Hey guys, today what we're going to do is we're going to look at just a bunch of different examples of tertiary ionic compounds. And the goal is going to be, for some of them, can you name them? And for others, can you write the formula for it? So here are the first six, and then I'm going to show you the answers for the first six, and then we're going to kind of take some time and go through each one individually. So here are the first six, here are the answers. Oops, bam. There we go. Okay. So you can pause it right now if you want, or you can not. It's up to you. But we're going to talk about how do we get these numbers. So how do we, for example, know that niobium has a 5 here? How do we know that it's parentheses around the NO3 and you have a 3 here in question number 4? For question number 6, where did we get the MnO4 from? And why do we have a parentheses 4 next to it? All those questions and more are going to be answered. Here we go. Okay. So for the first 3, these are all naming rules. So the rules for naming are name the anion, so the SO3, and then name the cation, which in this case is CS. And then you have to look and see, does CS in this case have more than one charge? So in every single problem here, the first thing you're going to have to do is look at the ion list on the back of the periodic table. On Schoology today, I've shared a copy of the periodic table just in case you don't know where yours is, just so you can take a look at that and take a look at the ion list. For the purposes of these questions, I've just kind of copy-pasted what it says on the ion list and where they're located. So for example, cesium just says 1+, and it's number 9. Oops, this is the wrong one. I picked sulfide instead of SO3. Oh well. It does have the same charge though, so that's kind of nice. What we're going to do now is we're just going to kind of see, okay, I'm going to need 2 cesiums and 1 sulfate, SO3 minus, or SO3 2 minus. Here is the compound ammonium and hydroxide, and here is niobium and phosphate. So I've kind of listed all the ions you're going to need. So if you want to take a moment and do the problems now, you can go ahead and do that. Great, pause the video if you need more time. Here we go. For the first one, cesium, we're going to need, this is going to be cesium and SO3 is going to be sulfate. So the answer here is just cesium sulfate, cesium sulfite, because this is ITE sulfite. Sorry that I have the wrong one here. For the second one, NH4 is called ammonium, OH is called hydroxide. So the answer here is just going to be ammonium hydroxide. Again, really straightforward. This third one is going to be a little bit more difficult because we have to figure out, do we use the 3 or do we use the 5? We know that phosphate in this case is a 3 minus, and there's 5 of them. So that means our total negative charge is -15. So we're kind of just taking 3 minus times the 5 here. So then our positive charge has to be +15. We have 3 niobiums. So kind of think, okay, +15, divide that by 3, you would get +5. So in this case, we're thinking it's niobium 5 phosphate. That's kind of how we got the answer there. So a little bit of math there in that last problem, but for these two, pretty much what you're just doing is you're just looking at what the periodic table gives you and copying that down, since in number 1 and 2, both of our cations only have one possible charge. But here, niobium, number 31, has 2 different charges, so we have to write that Roman numeral there. And then again, sorry, yeah, this should be sulfite, not sulfide. Sulfite is SO3 2 minus. Okay, up next, a little bit more difficult. You kind of have to look at the charges here. Aluminum nitrate is the first one. Then we've got copper 1 phosphite. Then manganese or lead permangate. So once again, go ahead and take a moment if you'd like right now to kind of figure it out. Cool. I want to show you guys the ions here. Awesome. There they all are. For the first one, aluminum is 3+, nitrate is 1-. So we're going to need 3 of these nitrates for a total of 3- to cancel out our 3+. So that means we need 3 nitrates. So it's going to be Al, and then we need 3 of these NO3s. So it's going to look like Al, NO3, and then in parentheses here, we're going to put a 3, saying that we've got 3 of them. Copper 1 phosphite, in this case, copper is going to have a charge of 1. That's what that Roman numeral is saying. Oops, that 2 there it shouldn't be a 1 over there. Sorry about that. copper 1 phosphite, and then phosphite has that 3 minus, so we're going to just need one of these 3 minuses, but we're going to need 3 of these coppers. So 3 coppers, 1 phosphite is going to look like this, Cu3, PO3. Notice that PO3 is all one thing. You need the P, the O, and the 3 to say that it's phosphite. So that's why there's only one of them. Sometimes people look at this and think, oh, I have 3 phosphites here. But remember, phosphite has the formula PO3. So the P, the O, and the 3 are all equally important. That's why we have the formula written as such. For the last one, lead 4 permanganate. Permanganate has a charge of -1. Lead, in this case, since it's 4, is going to have a charge of +4. That means then that we're going to need 4 of these MnO4s. So again, Mn, the O, and the 4, all of those things together make permanganate. You couldn't just write down Mn. You couldn't just write down MnO. You have to write down MnO and 4. So in this case, we need 4 of them. So that's where the parentheses 4 is going to come in. Just kind of like how we had a parentheses around the NO3 and put 3 down. So PbMnO in parentheses 4 is the answer there. Just because lead has a charge of 4 and permanganate has a charge of 1. So we need 4 of these permanganates and 1 of these leads. Hopefully that makes sense. Let's move on. We've got kind of 6 more examples. Again, I'm going to do the same thing. I'm going to show you the answers, then I'm going to show you the ions, and we'll kind of go through each one. Great. Okay, so if you want to take a time to pause the video right now and work on these problems yourself, you can. I'm just going to show you the answers now, so pause the video if you don't want to see these. Here they are. Hopefully you got these answers. Let's talk about how I got them. Here we go. Okay, so for the first 3, we're writing formulas. So the big thing we want to keep in mind, or sorry, we're not writing formulas, we're writing names. So the big thing we want to keep in mind is, do we have multi-charged metals? In question number 7, the answer is yes, iron has more than 1 charge. In question number 8, the answer is no, calcium only has 1 charge, its charge is 2+. And for question number 9, the answer is no, yttrium only has 1 charge, its charge is 3+. So for 8 and 9, we're not going to have Roman numerals, and for 7, we will have Roman numerals because we see it there in the name on the ion list. Cool. So in this case, we can kind of pick between 2 and 3. We know oxalate is 2-. So if iron was 2+ here, they would just be 1-to-1. Instead, we see that it's 2-to-3. That means that we have a -6 charge from our 3 oxalates, our 3 2-. So 3 times 2- gives you 6. And then over here we have 2. These 2 irons have to add up to +6. So our charge here is going to be 3 because each iron has a charge of 3. Cool. For the second one, very simple here. It's just calcium nitrate. There's nothing really else to figure out. We know calcium doesn't have more than 1 charge, so we don't have to do Roman numeral. Just write the name of the metal, the name of the nonmetal. Kind of easy. And then for the last one, same thing. We know Y is yttrium and ClO4. Oops, that's not chlorate. That's actually perchlorate. So this is actually wrong. Let me change that. Perchlorate. Sorry, there's so many mistakes here, guys. That's my bad. Okay, let's go ahead then and move on to the next 3 examples. Here we go. Okay, question number 10 is lithium benzoate, uranium 4 selenite, and barium perchlorate. So I'm going to go ahead and show you guys again kind of these things from the ion list. For the first one, it's 1-to-1. 1 plus to 1 minus, so that's kind of nice. You're just going to write down Li, and then you're just going to need 1 of these C7H5O2s. Benzoate's got a really complicated formula, so it's important that you include the C, the H, the O, and the number of C's, the number of H's, and the number of O's, kind of just like this. So notice in my formula, I have C7, H5, O2. So all kind of 6 of those things need to be included. And then I just write down Li next to it so that I have a 1+ charge, and then this whole thing here has a 1- charge. That's the formula. If we had more than 1 of these benzoates, we would kind of put parentheses right in here. Oops. Sorry, parentheses right in here, and then we'd write a 2 or a 3 or a 4. For uranium selenite, we have uranium 4, which means our charge is 4. Compared to selenite, we have a charge of 2 minus. That means we're going to need 2 of these selenites because 2 times 2 gives us 4, right? And we want 4 and 4 on both sides. So we're going to need to put a parentheses around SeO3, that whole thing, and we're going to need to put a 2 right next to it on the outside, which is going to look something like this right here. Okay, and then for the last one, we have barium perchlorate. ClO4 1 minus is perchlorate. It's not chlorate, like I said in the last slide. Sorry about that. So barium perchlorate, here we go. We have 2 plus on barium, and we have 1 minus on perchlorate. So we're going to need 2 of these ClO4s. So that's going to be ClO4 in parentheses 2, just like this. So notice that the parentheses are there, and I've got a 2 there. The idea here, as we said previously, just to kind of rewind quite a bit, with polyatomic ions, is that you only use parentheses when you have more than one polyatomic ion. So you would only use parentheses here when you have a 2 or a 3, saying that I have 3 NO3s to balance the charges out, or I need 2 of these NO3s to balance the charges out. You would never put parentheses around regular old atoms like Na, for example, and you still wouldn't put parentheses around when you have 1. And then lastly, there are some times where you need to put parentheses when you have polyatomic ions. So for example, it wouldn't be CaOH2, it'd be Ca parentheses OH and parentheses 2. Hopefully this helps clarify parentheses stuff. Hopefully this helps clarify some of the polyatomic ion stuff. The hard part is finding it on the periodic table. As you might have seen there were a couple of times where I found the wrong ion. So very challenging. But I hope this helps. I hope you guys have the courage and the strength to kind of practice these out. And I hope you guys have a great rest of your day. Thank you so much for tuning in. We'll talk to you later.